All right, welcome to another edition of the Rust Munich Meetup. This is the third edition of the hybrid meetup. That's what you're seeing, either here live or behind your laptop screen. Today we have Motius, and the people from Motius are going to present themselves real quick.
Okay. No, you didn't. Hi, everyone. Thank you for taking the time to come to our office and to obviously join the Rust meetup. It's an awesome, massive pleasure to host it here. We do a 5-minute introduction of just who we are and who our company is. My name is Andre. I'm a project owner here. At our company, we kind of mix project and product management a little bit and combine it into this role where we help our customers or enable them from conceptualizing their solution all the way until it gets rolled out in a POC or some kind of prototype. My background is in geodesy and software engineering. So in this role, I also take a bit of a technical approach for solution architecture and work along with managing the engineering teams and working with our partners on a regular basis.
My name is Sebastian. I'm the hardware cluster lead, and I make stuff. We are an R&D company, and what that means is we do projects with our customers. They come from all industries, and we do all kinds of different weird things. As you heard, hardware cluster lead means we don't just do websites and stuff, we also do real things. So I have a team with electrical engineers, with mechanical engineers, and embedded software developers. An embedded software developer is like a programmer, but the computer he programs for is actually interesting and not just a boring box in the cloud. As I said, a lot of different kind of projects. I think what our customers can get here that you don't usually get is that we can make a concept for your weird e-bike idea, and then we write the software for your weird e-bike idea, and we also build you an e-bike if you have the money for it. We have been using Rust at this company already. It's a little bit of a harder sell for us. We do a lot of prototyping, a lot of very quick turnaround stuff. That also means, using a lot of pre-existing stuff. So that's a little bit harder kind of to get Rust into these kind of projects. For example, we do embedded projects with microcontrollers. So for example, if you use an NRF52, that's a special microcontroller that has really, really good Rust support because of two specific nerds who basically do all the work that the actual chip company doesn't do. So in this case, we're lucky, but in a lot of other situations, we do a lot of robot stuff. All of that crap is in C++. But we're slowly sneaking Rust into more and more of our projects. And I guess that's all that I can come up with.
Nice. And we'll wrap it all up with this quick slide from the department who sponsored the food. We also maintain a super massive talent pool with working students and freelancers, or even people looking to change in the near future. In our talent pool, we have the ability to approach, especially working students and freelancers, with once-off quick projects, or even engage in long-term commitments. So if you are interested, have a look on our website. That's it. Thank you for your attention.
Do I have to put this microphone on? Or? Okay. Yes? Should I click it? I'm just waiting for that. Oh. Am I sharing my screen online? I think I do. Yeah. Whoops. Perfect. Okay. Hey, I'm Philip. I'm one of the maintainers of Clippy, and today I will talk to you a little bit about Clippy, a little bit about the Rust compiler, and some dog food. Short introduction about me. Maybe you know me on GitHub on the name Flip1995. If you ever contributed to the Rust compiler or Clippy, you might do. Otherwise, probably not. I'm working on Clippy since 2018. I think I got a team lead by 2020 or something like that. Can't remember. And I'm the #1 Clippy contributor by number of commits. But I want to highlight that by now it's only the number of commits, not the quality of the commits. We have so many great contributors in Clippy that contribute way better code than I do. And in my day-to-day job, I work at Recognize with C++, which is the reason why I am so involved in the Rust ecosystem, so that C++ finally dies in a few years. I really hate it. Thank you. Okay, so you're also involved in this presentation, and you represent everyone that's online. So we play a little game. When a slide, show of hands, comes up, I count down from 3, and then you raise a hand, either left if you're yay, or right if you're nay. And then I will know where you stand on the question. So do you like puppies? 3, 2, 1.
Yay.
So split between yay and nay. I love them, so that's good. Okay, that works. You can just raise your hand. I won't ask you any questions after that, so just raise your hand. I ignore you after that. I just want to get some feedback how long I should talk about the things I will talk about. So first question, have you used Clippy? 3, 2, 1. Okay, most of you did use Clippy already. That's really good. So I can talk about this real quick. But I may introduce you to some features of Clippy that you might not know yet. So if you never used Clippy, you might be able to just use it because it's probably already installed with your Rust installation, because Rust installs it automatically. If not, you can just add Clippy. It's really convenient. And if you can use cargo check or cargo build, then you can also use cargo Clippy. And if you don't want to use cargo, you can use Clippy driver instead of Rust C to lint a single file. Useful for some really small projects that you want to also lint with Clippy. So Clippy driver is the replacement for Rust C. And maybe something new you didn't know about yet is Rust and Clippy error messages have suggestions, and those can be fixed completely automatically with cargo fix, or for Clippy, cargo Clippy fix. And I have a live presentation of this. So we have this program here. You see bar will have a Rust C warning where X is unused, and foo will have a Clippy warning where we assign X to X plus Y. Let's run cargo check, and we will see, okay, this variable is unused, and a suggestion here, add an underscore. And you don't have to do this by hand. You can just run cargo fix. And then if we look at the git diff, we see cargo fix added. I move it up. So, yeah, cargo fix added the underscore. Same thing for Clippy. Clippy will tell you here, hey, you can just use X plus equal Y instead of X is X plus Y. And then we've got, okay, we have changes in our thing. Clippy or cargo Clippy fix also fix the Clippy suggestion for you. This is really useful if you have use Clippy for the first time on your project and never used it before and get like 20 Clippy warnings, then you can just run cargo Clippy fix and it will fix hopefully most of them for you and you don't have to go through all your code. But it is important that you don't just blindly commit it, check your code after that and make sure that every suggestion was applied correctly. And if not, come to the Clippy repository and report the bug. So, newest thing in Clippy, we now have a book. Like most other projects, where we document what Clippy is, how you can install it, how you can use it. Also, really only many other use cases you might have. And we are working on extending the book. Am I moving too much? Perfect. And yeah, and we also have a documentation for every lint online, where you can look at a lint. It tells you what a lint does, the explanation why this lint exists. It has an example what you did wrong, or might did wrong, and what you should do instead. Yeah, and all the good stuff. And if you're offline, you can use the explain flag, and you get your explanation in the terminal. So, like this. So you just get a documentation in your terminal. Also pretty useful if you don't understand the lint. The same thing is also possible with Rust-C explain and then the error code. Okay, that's about how to use Clippy. Next question. Did you contribute to Rust-C or Clippy before? 3, 2, 1. Okay, as expected, mostly nay. Now comes the interesting or not so interesting part, depending on if you like compilers. But yeah, I will try to explain it at a pretty high level. So how does the Rust compiler work? So the Rust compiler is built into layers. So the first layer, you get your syntactic check. Did you set every semicolon you should set? Did you use the correct brackets and so on? The second part is where all the type checking, type inference happens so that you don't have to type every variable you use. And it also has some desugaring. So in the second level, you don't have any for loops anymore. All for loops in the Rust compiler get converted into an infinite loop plus a match statement, which has a break. So this is how the compiler sees your for loop. This happens in the HIR, high-level intermediate representation. Then in the MIR, this is where borrow checking happens and all the good features of Rust, like also the constant evaluation. I don't know much about the MIR, so don't ask me questions about this. This is really complicated stuff. And the last level is then LVM, IR, or other backends that then compile down to your hardware. And the Rust compiler, like all things Rust, implements new concepts. So not the old stage by stage like GCC or LVM does and Clang does, but Rust implements something like queries. So this enables incremental compilation so that if you change something in your code in one function, you don't have to recompile your entire crate, but you only have to recompile this function. And this is what Rust compiler uses queries for. And you can, for example, call expression type query, so to get a type of an expression in a Rust compiler, which then executes another query, and if the result is unchanged to the last compilation, then it just returns the cached value. Okay, that much about a Rust compiler. So how does Clippy work? Clippy is mostly just a bunch of if statements chained together. Is this an expression? Is this expression an assignment? Is this assignment blah, 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 and so on. And writing Clippy lints is pretty easy because we have this Clippy author attribute. And if we run Clippy on this code, it will dump you what you have to put into Clippy if you want to contribute here. And this is pretty much a representation how the Rust compiler and how Clippy sees your code. this is a statement. A statement kind is a local, which is an assignment. And then the local has an initialization. Initialization is a binary operation. Binary operation is multiplication, and so on. And if you want to write a Clippy lint, this is the first thing. You write your expression you want to lint, you put Clippy author on it, and then run Clippy on your code or in the playground, and Clippy will give you what you have to put into the source code of Clippy to lint your code example you just put in the playground. This is pretty cool. And because Clippy is a linter, this Clippy author attribute is pretty much just a lint. So in Clippy, we pretty much implement everything as a lint. So we use a lint to write lints. Lints all the way down. And also for contributions, we have great documentation in our book. And we have getting started, we have the basics, we have how you can add lints, how you can write lints, and we're currently working on improving that. So if you're interested in getting into compilers, into static analyzers, or generally contributing to the Rust ecosystem, come to Clippy. We are open to new contributors. We have issues, we mentor actively. So just write on an issue that you want to fix or work on. And we will mentor you and explain you how you can fix the issue. Okay, dog food. Next question. 3, 2, 1. Okay, this is half-half. So dog food is eating your own dog food is the practice of using one's own products or services. And that pretty much means for Clippy, we use Clippy to lint Clippy so that we don't have any Clippy warnings in Clippy. And we extend the lints that you get from Clippy with additional internal lints in Clippy, so much Clippy, to lint some Clippy internals. And as I mentioned before, Clippy author is also just a lint. And our documentation you saw before, this one is, of course, produced by a lint. And yeah, those are the groups that we use to lint Clippy. So we use the Clippy all group, which is enabled by default. If you just run cargo Clippy in your project, you will get all those lint groups. But we are really pedantic about Clippy because we like our own lints. So we also use Clippy pedantic to get even more warnings and more not annoying, helpful warnings. Yeah, and then we have our own internal lints. The internal lints are lints that if you contribute, you might not know how the Clippy code base is structured and what you can use and what you can't use or shouldn't use or how you use it. And for the parts we can check automatically, we have internal lints that will tell you your contribution is wrong because you should have used this utility instead of this utility. Yeah, this makes reviewing PRs way easier because you don't have to think about so much things. And there's currently a project by a Clippy team member called Rust Marker. So if you want to write your own lint for your own crate that you're producing, you can go there to Rust Marker. I think it's /design, not marker, and post your use case there. He's open for suggestions, what you need this lint infrastructure for, and maybe in like a year or so, you can also write your own lints for your own crate and publish them. But yeah. And last but not least, we document our lints with a lint. And this is also by the same guy who implemented this. That's why I said I'm not a #1 contributor of quality. We have great contributors that implement things like this. So before we had a hacky Python script that generated our documentation. Now we have rewritten it in Rust, in Clippy as a lint. So the first question, should you rewrite it in Rust? Yes. This applies to every project that is not written in Rust. And the second question that applies to Clippy, should you use a lint for it? Yes, so we did that. So, any questions? Who were first?
So, yeah, thanks for talking. Awesome.
Thanks. If I'm writing a procedural macro, like sometimes I need to check that the code is using it properly, that it's not putting some syntax that my macro didn't expect. And sometimes my macro can be hard to use because I didn't thought of something or I want to encourage using it in some way. Like, is there a way to reuse some of the infrastructure that Clippy has for linting when writing procedural macros to be able to kind of lint?
Yes, so what Clippy does is Clippy uses the Rust compiler to do all the heavy lifting. So all this check your syntax, check your types, do type inference. All this is done by the Rust compiler. And Clippy just uses the API of the Rust compiler. So there's, in theory, no thing that stops you from pretty much writing a linter using also the Rust compiler. It's like 100 lines of boilerplate you need to run the compiler and include your own lints. And then you can write your own linter for your own grade. But there's currently also this project that tries to implement a stable API for the Rust compiler so that writing lints gets even easier. But currently, you will have to write your own Clippy. You can just copy the code from Clippy, and then you can write your own lints for your own project.
But there is no way for me to kind of extend Clippy with a lint from my project somehow, and then my macro just expands a Clippy with my custom lint somehow.
Is this dialint tool? So dialint uses all the utilities Clippy has already implemented as a grade, and you can write your own lints. And I think it's a little bit easier to do it in dialint. It's by some company, I don't know which, but you might be interested to look into this.
Cool, thanks.
I think there was a question.
Okay, thanks for the talk. I'm wondering, earlier you talked about that most of the analysis done is pattern matching. Are there other kinds of analysis that are more complex that you can maybe give a little small, like?
Yes, of course. Everything that has something to do with types, pretty much. So when it comes to, for example, when it comes to checking, did you use an additional reference that you don't have to use because Rust will auto dereference it or something like that? You will have to check, if I remove this reference, is it still correct Rust code, which is pretty hard to do. So all this type checking and all to predicting what will the borrow checker do with this new code, this will involve really complex Rust API calls, and those Rust queries I talked about, those are really helpful to get types, to get adjusted types, or what Rust thinks your type actually is, and then figure out, can I remove this reference or can I not remove this reference, or can I remove 3 dereferences or not? So yeah, when it comes to type checking, and the next even harder part is when it comes to one lint of ours is redundant clone. If you use clone and you don't have to use it because it's the last use of the variable and you can just move it, then Clippy will tell you can remove this clone. This will require MIR, mid-level intermediate representation analysis, and then you have to do a data flow analysis of your Rust code. And I don't even know how to do this. We only have limited lints because it's really hard to maintain things like this.
Okay, thank you.
Yeah.
I have a question.
Cool.
Thanks. Yeah, thanks for the talk. One question regarding suggestions that Clippy does regarding, for instance, trade implementation. So there is this, if you implement into, it suggests you to implement from because it can do vice versa, right?
Yep.
How does Clippy know about those meta information about traits and their, for instance, their syntax? Let's keep it simple, not their, their assets, but even the syntax of the suggestion that it does, for instance. Right?
It's pretty much hard-coded. I mean, Rust is stable and backwards compatible. So if the documentation states from can be implemented like this, and we can just hard-code a suggestion to, and then Rust fix will just copy whatever we give it and replaces your code. So it's not that much of magic.
Yeah.
It's really just hard-coded. If we find a impl into, we hard-code as suggestion, use impl from for your type, and then we pull the type out of the into implementation you did, and then compose the new implementation.
Yeah. Okay. Cool. Sounds more easy than I thought.
Yes.
Cool.
Maybe it's not that hard, so you can contribute.
Cool.
Okay. Another question? Yep.
I would love to know more about your experience as an open source contributor. Do you feel like you have enough support? Like, do you think you could make a living out of it eventually, or is that even a goal of yours? How's that going for you?
So making a living out of open source is not going well for me. So I have a project grant from the Rust Foundation, so I get $1,000 a month from them, which is really great already. But with $1,000 a month, you can't live in Munich. So then I have additional sponsors on GitHub from like one company or two companies, which is also a little bit of money, but doesn't get you anywhere. If you want to become full-time Rust compiler or Rust Clippy engineer, then you will have to go to Amazon or Facebook, or I think Microsoft also has a team dedicated to the Rust compiler. So not good news about open source and money. You can do it, but it's really hard and a lot of work to get your sponsors together. And but I never really tried doing it full time. It's more hobby on the side, and if money comes in, then great. If not, I do the same without money. It's just passion for Rust and for Clippy.
Awesome. Best of luck. Thanks for the talk.
Thank you. And one question here.
Thanks for the question. I want to ask, do you have any plans on new features for Clippy, or what are the biggest challenges that you want new people to contribute to? Is there a project roadmap that we can see?
Yes, so many plans. We have a roadmap. The roadmap is called Roadmap 2021. We are at the end of 2022, and I don't think 20% of it is implemented yet, because Clippy maintainers are busy with reviewing code most of the time, or fixing bugs that have to be fixed right away, and so we don't really get to it. One project, for example, I want to work on as soon as possible when I have time is that you can specify your lint levels in an extra file or in the cargo toml file. This is currently not possible. Like in Python, you can, for PyLint, I think you can have an extra file where you define lint levels and lint configurations. I really want this in Rust, and I want to work on it, but I don't have time. Another thing we want to do is implement nightly lints, which is a feature that we want because currently it's possible that a lint lands into nightly, then it's 2 weeks in nightly, then it gets to beta, and after beta, 6 weeks later, it gets to stable. So it has like 8 weeks of testing. And if a bug comes in, we have to do some backporting and really much work to get a bug fixed before it lands in stable. And we want to fix this by having nightly lints that will first only be included in nightly toolchain. And then once we say, okay, this lint is ready, we can ship it to stable. This is another big project. The guy that works on the lints for custom crates wants to work on it, but doesn't have time. So those are two examples of projects we have planned, and we have a Rust roadmap 2021. There are many more projects in there that can be addressed.
Cool. Thank you so much.
Okay. I think we also have other talks, so and I'm hungry, so I will go to the pizza. Thanks for the questions, and have a nice evening.
All right. All right. Next up is Frederick, talking about generating zero copy parcels. Stage is yours.
Hello. I'll put some contact information here in case someone has questions. The offer is also valid after I finish the talk for those who are watching it online. And if you choose a Telegram option, like hurry before the username gets repossessed and turned into NFT. And I'm sure you know that you should use this fork that lets you own your own data Today I would like to talk to you about a smorgasbord of assorted ideas from the wonderful world of file formats. File formats are usually these annoying things we have to deal with before we can get the data that is trapped in some file on our computer. And hopefully there would already be a crate you can that's download, install, that already parses a file for you so you can access the data. But that's not always the case. And even when this seems like there is, you cannot really trust the quality of these crates. So verify, don't trust. The first step in dealing with a file format is search the internet, because there's usually a specification for the file format. For example, let's see if I can get the toolbar away. Here's an example of a specification for the zip format. And this is what specification usually looks like, this very old document that like no one is really maintaining, and no one has done any work on making it well formatted or easy to read. Neither has anyone checked that there is anything correct about it. But if you're working with this file format, then you would have to look at these documents and try to get all the details right, all the nasty little details. And also search to see what's already there. Don't just make your own parser for a file format without seeing what other people have already made. And like, if you're serious about the correctness of a parser, don't use something someone has already made without considering making your own, at least see how this works. So here I search for zip on crates.io. There are 6 different options available. Or you can try lib.rs if you don't have time for the JavaScript code from crates.io to load. So I tried all the 6 different crates for zip files I found. I can tell that they all parse 6 different file formats that are almost like zip. Well, actually, the specification of zip doesn't tell how to read the first piece of information that you need in the file. A zip file has pointers around to different parts of the file that you have to follow to access the different data structures. But nowhere in the specification is it told how to find the first pointer. So every zip reader has to find a way to search for the first data structure, and all of them do it in a different way. So with 6 different parsers for zip files, I can feed them 6 different zip files to have one file that parses uniquely in one parser and not the same in the others. Some parsers would panic, or a zip file will be recognized in one parser but not the other, or I can even make a zip file that contains 2 different files depending on what parser you're using to open it. So I can make a zip file containing a picture of a very harmless kitten when you open it using one zip file parser, but when you open it in another parser, then there's malware.exe inside this zip file. You should also consider fast testing any parser for a file format. There are good tools for fast testing in Rust. It means that the computer will automatically generate different variations of the input to see if your program goes wrong. You could fast test one parser against another to see if these are coming up with 2 different results. That's one way to find areas where they could be incorrect. Now, when you want to parse a file, first thing is to decide how to open and read the file. Well, Rust makes it pretty easy to open a file using this file structure in the standard library. But would you read directly from it? Usually you're reading very small parts of a file, one after the other, and it's not that efficient. So there's also another option called buff reader. You take your file, wrap it in a buff reader, and it will read 8 kilobytes of the file when you do your first read to this structure. And if you read another little piece of the file, it will just read from the internal buffer without going through the operating system and doing the system calls to access the file system. Another option is to read the entire file at once, and then you have it in memory, which means it's faster to access, but if it's a big file, you don't really want to load the entire file before you start doing anything with it. You might just want to read a small part of the file. Another option, if you choose to go with loading the entire file into memory, then you can wrap it in a cursor. This allows you to access the in-memory buffer in the same way as if it was a file you opened using the file structure. So it implements a read trait, and you can make a generic parser that takes anything that implements a read trait. So it's up to the user of the parser to decide if they want to give it a file or like in-memory buffer or something. Or next option is a memmap crate. They might not be very confident in you using it since it doesn't even have a README file. But if you look at all these old file formats, it's really interesting to see what people were thinking at that time. All these specifications, like historical records of different ideas and ambitions, all the different designs. When someone came up with a great idea for a file format, sometimes many decades ago, that another person just reinvented today without knowing that this good idea was already there. Or they came up with an idea that they thought was great at the time but seems horrible now. In any case, so many file formats are obviously designed to be memory mapped. This means that instead of you opening the file and reading from it, you just tell the operating system, I want this part of the address space of the computer's memory to be linked to the file. So when you read from the memory, the operating system will, if the memory has not been filled yet, go to the file system and fill it in from the file. Now let's see at a benchmark. So there is this tool called Criterion RS that is made after the ideas of the Haskell tool called Criterion. It allows writing some very short code and benchmarking it, see how long time it takes to execute. And it can be things that take very little time to execute. These things are measured in nanoseconds. So even a difference in one instruction will show up on the benchmarking results. Now it's not very exciting to look at the original implementation of Criterion RS with plenty of boilerplate code and like text-based console output and like HTML reports. So let's have a go instead. It's a good idea from the 1970s. But unfortunately, most programmer tools today haven't really adopted this idea yet. I think they should. There should be a GUI for everything. I guess the font size is so everyone can see it. So this GUI lets me interactively put in the input to these benchmarks. I want to open a file and read from it once we can speed it up. Let's run shorter benchmarks now. There. Or I could do the same with a buff reader. So if we just do one read from the file, the buff reader is obviously slower because it would have to read 8 kilobytes, whereas here I just read 4 bytes, or maybe it's 8. We could see how it increases. So if I read from the file more than once, then we can see that the time it takes increases linearly with as many reads as I do. Whereas if I use a buff reader, the time is pretty much the same. So after just like 2 reads, the buff reader is already quicker. We could also try to memory map the file. Memory mapping is a lot slower to get started with, but then reading is very quick. Let's try to do much larger reads. 1, 10, 100,000, 10,000, 100,000. Now this takes so long time, so the benchmark cannot do enough samples in the time I have requested it to do it. I can prepare the memory map in the meantime to do many reads. So buff reader doing really well. We can remove this one to compress the range of the plot. So memory mapping is faster than buff reader. Now often the file format isn't designed to be read linearly. You have to seek around to many locations because files contain pointers. So if you seek in a file, then well, just using a plain file will work as before. It increases linearly in time, but so does a buff reader. You don't save anything by using the buff reader. It's actually slower because the file has to read 4 bytes every time, whereas a buff reader reads like 8 kilobytes to fill the buffer. And if we run more of these, we can find it like using a cursor is also a bit slower than if we just access a memory directly. But let's move on. So next thing you care about when you're parsing file is often to parse a list of something. And what I see many parsers do is put it in a vector just read it one item at a time from the file and add it to a vector. The documentation for vector is interesting to read. It tells like all these characteristics about how the vector is resizing and reallocating memory. Something you should care about if you're going to add things many times. It also offers this option to allocate the vector with some capacity before you start adding the items to it, so it doesn't have to reallocate. But another option that is often even better than a vector is a boxed slice. I see a lot of this vector type in parsers, but what you want is often a boxed slice because you don't want the spare capacity at the end. You already know how many items you're going to read, so you can allocate that number of items and not anything more. And then this box doesn't have to store any extra information about the spare capacity like a vector has to do. And then another great option that I think is very useful in parsers is that instead of allocating everything once we parse each item, we can have a pool that like allocates a slice of memory in one big batch, and then you reuse small slices of this memory as long as you can, and then when it runs out, it will allocate one more big slice of memory. I do have a benchmark for that too. We don't really need to look at this. I'm just going to start a benchmark. Okay, benchmark is building. So in this benchmark, I'm simulating taking a sequence of items and then adding them to a vector. Now we're actually not reading them from a file here. It's just a constant number that we're adding to the vector over and over again, but this number has been black boxed, so the compiler cannot optimize it away. So if we do a small number of items, let's see what happens. can do a few more too. So in the first case is with us using default constructor of a vector, which means that it has not pre-allocated any memory. Once we push to it, we can see that pushing a few items, that doesn't really take much more time than pushing one item until we push 5 items and it has to reallocate. So it takes longer time. Whereas the one that has pre-allocated a certain capacity, it's much faster. But you should probably only use it if you know the exact capacity that you need. If you don't know it, we're simulating that by allocating the required capacity -1. And we can see that this is perhaps even slower than if I did not specify a capacity to allocate. Let's do some more of these to see how it scales. I think the pattern here is interesting, that we have 4 items and it reallocates, so we can very clearly see in the benchmark results exactly when the vector reallocates. An interesting thing here is that first it allocates after only 4 items, then after 8 items, and then it doesn't allocate so often anymore. So it will allocate half as often every time it reallocates. This means that the vector has an amortized constant time of allocating. So if we're going to allocate a number of times that, or add a number of items that approaches infinity, then the amount of time the vector is spending reallocating it's going to approach a constant. It's not going to go up to infinity. So if we do really large numbers, we can see that the vector that has its items pre-allocated is not any slower than the vector that does not have items pre-allocated. They differ very insignificantly when we come up to a larger number of items. But what we can do that is even faster is to not push the items to a vector at all, but to let an iterator from the standard library automatically take care of that. There is the collect method on iterator, so we can collect into a vector. And this is about twice as fast as pushing items to the vector because it doesn't have to check whether there is sufficient capacity every time it pushes an item. Then I see a lot of strings used in parsers. And they typically have the time string, which is not a very Rust-like way to do it. So here we are simulating like a parser that would allocate a new string for every item and then add it to the parse structure. Here we're simulating one that does not allocate a string, but instead as a string slice, it points back to the original file into your parse structure. We can see this is much faster. This is what you should do as often as you can when you're making a parser in Rust. make it a zero copy parser. One that just has a reference that points to the original file instead of copying. Sometimes, however, you cannot directly copy the string from the file. It depends on certain conditions. In some formats, the string might need to be decoded in certain cases, but others not. So then from the standard library, we have the cow type, stand for copy on write, but they're typically not used for writing anyway. We just use them because sometimes we want to borrow the original data, sometimes we want to allocate a copy. Like if we have some decoded data that is not in the original files, we can just point to it. And here, if I use a calc type and I can point to a slice from the original file, and it's much faster than allocating a string, but not quite as fast as if I just use a string slice without wrapping it in the calc type. And if I'm not able to copy the original string, the calc type lets me have a borrowed string inside it. And this is going to have very similar performance to if you're just parsing into a string. But then an option I like better is to create bump along it to allocate bigger chunks of memory. So if we need to copy this string data, then instead of putting it into a new allocated string every time, we use this bump arena to allocate the string. And it's pretty fast. It also matters how big these types are in memory. Now you cannot actually strictly rely on types being a certain size. Rust doesn't guarantee that the types are a certain size. Maybe in year 3000 a vector would be a different size than it is today. But you can assume that it's not going to change very often. So if you can make a program that has a bit better performance depending on how big the types are today, then that's usually good. Now we can see that if you put in a string slice somewhere, it's just 16 bytes, whereas an allocated string is 24 bytes. And often you're adding a lot of them in a parse structure. So it can make quite an impact. Now, cow, interestingly, is also 24, so we don't add any extra size to use this type. We can also wrap these types in an option, and they don't get any bigger because Rust has this thing called a niche. So if there's a certain integer value that would be invalid in this type, then the compiler can use this for something else. For example, if you're wrapping the type in an option. But in cow, it's already used, so we cannot wrap cow in an option type without making it 8 bytes bigger. So you likely want to parse some integers from a file format. Here's how to do it in a way that cannot panic in any way at all. We use a match expression to look up 4 bytes of the source slice, and then a slice that is the data that comes afterwards. Then we convert this slice into an integer and write this slice to what comes afterwards back into the slice that we're reading from. Now, I don't quite like this code because we have to write each byte separately. Now there are 4 of them. If we pass in 8 bytes, it gets even worse. I would have liked the standard library to have like some method so I can just take 4 bytes out of a slice and get an array of 4 bytes. But it doesn't, so we have to do workarounds, like first check is this slice long enough. Okay, then we split it using a method that can actually panic. But looking into Compiler Explorer, we can see that when we run the optimizer on this program, it cannot panic. Still would be so much nicer if there was some external library API that can just read a fixed number of bytes out of a slice, instead of having to hope the optimizer will remove the panic for me. And I can try a few different iterations of it, because there isn't really one way to do it that looks really like it should be idiomatic. We can make our own method for reading a number of bytes out of something using const generics. So it actually returns a fixed size array of the size that we requested. We can use macros to create functions for reading all the different types of different sizes. Another thing I see in parsers I find in the wild is that they try to copy some data from a file and put it into a Rust struct, which is usually not how file formats were designed to be parsed. Usually file formats were designed to be parsed in C, and you just have a pointer somewhere into the file, and then the fields of the C structure would point directly to the bytes in the file without having to copy them. Like we could do the same in Rust by declaring our struct as repr C, but then we would have to unsafely transmute the bytes into this type. And it's not really nice if we have to put unsafe code in our parser. There's a workaround. I can define a struct like this that internally contains a reference to an array of bytes of a certain length, and it has methods to read all the fields out of memory. So when we hand this around, we're not actually copying anything. It's just a pointer. And these methods are just one instruction that reads from the corresponding place in memory. And this will, of course, be inlined. And it would introduce a large risk of mistakes if we have to manually write all the offsets where to read in memory. What we can do is to write a little specification here of the shape of our record from the file format, and then use a macro to automatically generate all the accessor methods. Now, macros cannot really do math, but you can always do some like ugly workarounds on macros to try to do them what you want them to do. Like the token muncher pattern that you can read in the little book of macros. It gets quite tricky, but we end up with something which is the same as what we would write by hand, and no added cost to it. That's the rest of the macro. Now I've been passing this format called either true type or open type. It's a bit confusing that there are two formats that are almost the same thing, but one is defined by Apple, the other is defined by Microsoft. And we have a lot of these tables. I guess a traditional way to write a parser for this would be to copy this by hand, everything on the list, write it into your Rust code. But you could write a mistake and it also gets very tedious. And these tables get larger. These are the Macintosh encodings. But then the Macintosh languages is a longer list. And the languages for Windows is an even longer list. And then the list of vendors, it's an even longer list. And this list is actually maintained, it keeps getting updated. So we really don't want to copy this by hand into our Rust code. It would be great if there was a way we could make a program that reads the specification and then generates code from the specification. Now, we're lucky that there is an HTML parser made by Mozilla. So I can use it to parse the HTML page with the OpenType specification. It's a bit tricky to use. You have to implement that rate with 23 methods. And like if you're a serious user of the HTML parser, then you would implement your own presync. But if you want to make something quick and dirty, then there's a solution for that. There's also this RC-DOM crate that says, like, warning, do not use this for anything serious. But it really works if you want to get started quickly with parsing HTML. And it turns an HTML document into this like Rust structure that is pretty easy to follow. We have a node with references to its child nodes, and we can look inside the node and see all the different kinds of HTML features in it. But still, it gets super tedious to try to manually write some code to navigate the HTML nodes. Wouldn't it be great if we could have some way to specify it that requires less code? Someone might think of using selectors, like either CSS selectors or XPath, but it's not really a solution because like, they can only match like one kind of thing. They cannot match a complete structure with multiple things in it. And they also cannot implement a strategy for dealing with false positives and false negatives. So what I do here is a domain-specific language that describes the structure of an HTML document. And then there's an interpreter for this language that goes through the document and matches it according to this pattern. So inside this pattern, we have, just like in a regular expression, various captures. So when the interpreter is visiting this node, then it will put the contents of this node into the capture that we have numbered here. But still, this structure is very long. It would be good to have a more complex way to write it. So let's make another domain-specific language. This one that parses into the structure you saw on the previous slide. So what we have now is basically like an HTML template, like what web designers usually have. You take your database data, you feed it through a template, and it generates a web page. But we do the reverse here. We take a web page, we feed it through a reverse template, and it generates the data that was used to generate the original page. That way, I got all the information needed for TrueType and OpenType files. But there are other file formats where we don't have to be hacky and do with the HTML. For example, the Wayland Display Server protocol did things the right way. And they actually have a specification that is intentionally machine readable. So you can read the Wayland API in XML form. And from this, you can both generate documentation and you can also generate parsers in different languages. The only thing bad with it is that it's XML. Please don't use XML. Every time I do, a kitten starts crying rainbows. But how do we parse the XML file now? Well, there's an XML solution for that. It's called DTD. It's this obscure feature of XML that almost no one knows about. And out of the 4 different XML parsers on Rust, none of which parses a language that is quite like what's in the XML specification. None of them supports the complete DTD syntax. But if we have a DTD parser, then we can parse this Wayland DTD file to generate a parser for the Wayland XML file. So we can then generate a parser for the Wayland protocol. And the great thing is then that we don't need to do any testing. Since it's automatically generated from the specification, we guarantee that it matches the specification. And everything that the test is supposed to do anyway is to make sure that your program does what the specification tells it should do. Now, the XML specification contains a formal grammar of the XML. So to parse DTD in XML, we can actually generate an XML parser from the grammar that is in the XML specification. So we generate the XML parser, then generates the Wayland DTD parser, generates the Wayland XML parser, generates the Wayland protocol parser. This is starting to get a very interesting stack. And unlike other tech stacks where each layer means that your program will run slower, it's all just going to compile down to exactly what you would do if you had a big budget to have some code monkey write the final Wayland parser by hand in assembly. Unfortunately, the XML parser, the XML specification itself is written in XML. So in order to parse the XML specification, we need an XML parser. We have to find a way to bootstrap it. Like maybe make a minimal XML parser that only parses a small subset of XML that everyone agrees on and then panics if it's not in the subset, and run it together with all the other XML parsers and see that they all have the same result. Now, the XML specification itself also has a DTD that explains how to parse the XML specification, so we can get an even bigger stack. And then we can go to something really exciting. So not only Wayland doing things this way, ARM also released a machine-readable specification in XML for the instruction set. So if we can read the DTD file from ARM, we can generate a parser for the ARM XML format that can then generate a disassembler and assembler for ARM. And you can even use this XML specification to formally verify the ARM instruction set to try to see if there are any bugs in it. That's the way I would like things to go. But it's taking time to get all this stack of things. I would like to eventually have really good tools for it, so that we could have, for example, a specialized IDE where I can write patterns for matching web pages, where I can load a web page into one split screen and write the pattern in the others half of the screen, and I see a live update as I edit the pattern, what parts of the page are matched by the pattern. And I'm looking forward to see anything new that comes up in this area. And it's very exciting that people are starting to do this kind of things in Rust. So until next update, happy hacking.
Any questions? Are you working actively on that?
I am working a lot on this all the time, as much as I can.
How far are you? Do you have a timeline roadmap?
Yeah, so I have all these tools that work on my machine, but until I've done parsing the Wayland protocol with, I can't really port it to other platforms. But I have this GUI toolkit that I would like to run on every platform, so you can write your program once and compile it as a native code for any desktop environment and mobile platforms too.
Any questions? If not,
I have one here.
Yeah.
Can you throw this? Okay. I think it was really well structured. I kind of followed a lot of it. I tried, but my question is, what led you to start this journey? I'm very curious about how you decided to begin on this specific approach.
I've always been very interested in designing software because it's a software I like to have, and I've always been perfectionist about my software. So when it's about to be released, and then I find a better way to do it, and I keep rewriting things over and over again. So that's how I've been improving myself. And eventually I started to make a text editor. And I say a text editor is such a thing that in order to make a good text editor, you have to become a better person yourself during the time you're working with a text editor, because there are so many challenges in it. And then this programming language Rust came up that instantly makes people look into things that were considered taboo or impossible in other languages. So people are starting to learn about these really advanced techniques for making programs either have better performance or more robustness.
Nice. It's really exciting. I really like your passion there. Thank you.
I'm happy my passion is appreciated.
All right, our last speaker for tonight, Tobias, is going to talk about scripting havoc with Rye. Take the stage.
Okay, so wait a little bit with everyone. Still everything quiets down. Okay, so yeah, I'm here the last talk, and I'm just gonna give you a short introduction to Rye. So okay, so what actually is Rye? I mean, it's basically an embedded scripting language. It's a port of the C++ equivalent called Jai, which then in, I don't know, some kind of genius just changed the C, of course, to R for Rust. So we call it Rye. It's dynamically typed. It's similar to a mix between like Rust and JavaScript. It has like function operator overloading, a little bit to that later. Includes modules like you see them in Python, function pointers. Yeah, and it also is something that I at least find very helpful, or at least for the use cases later. It allows us to disable parts of the language however we want. So for example, if we say we need an IDL, but we don't want our like end user of this like IDL to actually be able to implement loops, we just like disable loops and set the recursion counter to 1. Then another nice thing about it is it's close to no dependencies. So in some other cases, you might say, okay, why wouldn't use, for example, Rye over something like Lua or Python? Well, for Python, you have to kind of like own your deployment environment completely. You need to be able to install at least Python. And for Lua, you at least have to statically link to it. And last but not least, also as we have nearly no like external dependencies, with the exception of the alloc crate, so you can actually deploy to Rye or a project based on Rye to no STD environments, as long as you, as I said, have an allocator in there, or, which is nowadays gaining a little bit of speed, deploy something to WebAssembly. If you do it as a like, I don't know, full stack web app or whatever, you can just like have your own little scripting language in there. Okay, so then the next question is, where do we actually make use of scripting languages? Well, for once, if you have like complex configurations, let's say, I mean, at least some of you probably are rising their desktop environments if you're running Linux, or have touched like a Vim configuration or a NeoVim configuration. And you often see, for example, in Vim configuration, they have their own custom scripting language called VimScript. And if you're going with NeoVim today, it's Lua. Or another a good example there is like more on the DevOps side now, an HA proxy, which actually provides you with a Lua interface where you can like create your own validation functions. For example, if you have an incoming web request, you can then do custom filtering based on it. The second part, which I touched a little bit already, is domain-specific languages. Like at least some of you here have touched or had the pleasure to interact with something like SAP or Salesforce, where they have their own like custom domain-specific languages, and at least I have never heard of something who actually enjoys doing it that. But something a little bit more closer to us as a programmer is oftentimes SQL, for example. SQL is nothing but another domain-specific language because our database servers usually run, or the existing big databases, you know, like Postgres, MySQL, or Go from Microsoft, are all based on C or implemented in C, C++. And they have their own little like domain-specific language we call SQL in there. And further, for untrusted content. Untrusted content meaning here, for example, we build something like AWS Lambda, where the user can just upload their own code, which then gets run on a web request, on some time trigger, or more traditional, or what's more traditionally, but where we also often see usage of custom script or embedded scripting languages, for example, in games, where people build their own like mods or extensions on it with, in most cases, Lua, or at least lots of like game engines provide Lua bindings, or I know at least a few of them that provide C# findings. And finally, whenever we don't want to recompile our code when changing like internal processes. So for example, you might not be able to deploy like daily, weekly, whenever. And as soon as you have a little feature request that comes in, you suddenly need to change this one procedure or put one offset into some kind of calculation there. I mean, you could put it into a configuration structure and then, let's say, parse the configuration file, but that gets tedious after a little amount of time. So it's oftentimes easier there to get some kind of, as I said before, get some kind of ideal there. And before you invent your own, why not use one already tested? So after that a little bit out of the way, let's continue to what can it actually do. And before we actually see the first code snippet, have a look. We're gonna have a little look at the performance of it because it's not that great. It's a little bit 2.5 times slower than Python. But yeah, it's some confused there. This is why. The main thing is, if you look at how Python actually works, it like takes a file and it then compiles it into object code, like Java does it with your object files, and that then get bundled into jar files. In Python, you don't see those object codes, which then get run on a VM. Rai instead does not do that. Rai just evaluates the est. So every time you evaluate it, it like has to traverse the syntax tree again and does evaluation of that. But the question here is, does it even matter if it's a little bit slower if it integrates very strongly with Rust? Because then, or what Rai is supposed to do is just be a thin dynamic layer on top of Rust. So if you invoke some or try to do some heavy computation, you don't actually do that in Rai. You just call like the Rust function underneath, and you provide like this dynamic interface where you can like pipe the outputs and call different commands. Think of it as a more complex bash script with Rust underlying it. Okay, so that out of the way. That's a quick tour. We will have like this 2 little snippets there. Let's start with the left one. That's basically it looks similar to Rust, and if you mix into a little bit the JavaScript and drop all the types. So first, the simple function declaration. Secondly, we have an offset set in the current scope, and then we create a closure. The kind of trick Rai is doing here, or I don't want to call it really a trick, but what you have to keep in mind is that in theory, or not in theory, but Rai runs on either without send and sync. So, I mean, how many of you know send sync? I guess most. The threads, yeah. You can either run the whole engine in shareable between threads or not. And if you don't do it, that actually does not take that much of a performance hit, and you don't actually have to like keep that in mind here. But what the closure actually does, it captures the offset variable, and it moves the offset variable here into an ref counted cell, which is okay if you use single threaded. If you enable sync, this gets turned into an atomic reference counter with an read-write lock. The thing on the read-write lock is now if you share this between threads or a different execution, and we don't know that we have the read-write lock in there, it's quite easy to deadlock. So that's just one of the things they don't really tell you, but you then be like, oh, why is my program stopping? Well, that's why. And the snippet on the right shows basically the import statement of a module. And so we import like our light sensor module, then we get the current status, and depending on what it is, we either print on or off. Rai here allows us, for example, if the import statement there calls in the background an module resolver, something like that, where you can actually implement custom code on how your modules get loaded. It means, for example, if you were to build like a CRM system, where, for example, different people are not allowed to access all the modules you provide for whatever reasons, you can actually put some kind of database calls behind the actual import statement there. Okay, now we take like this little snippet here, and we look a little bit into it, how we actually like link this RAI code here into Rust. It basically just imports an HTTP module, creates a new request, sets the request method to head, sends it, and checks it's okay. So more or less just an uptime, little uptime query script. Okay, so we have two ways to do this. That's the first one. RAI provides us basically with a POC macro that does actually all the heavy lifting for us. We define our structure outside this, and then we create our module, our HTTP module. We say, okay, we have those two types in there. Map those two Rust types. Please map those two directly into the scripting language. Then we have a few functions, a few methods, or one function, two methods. And the interesting part here, we have something similar like the C# properties, if you know them. They are, for those that don't know them, C# properties are another way to write getters and setters, as we see them in Java. But instead of like always do set underscore whatever, it allows us just to, give me a second. It allows us to just to the request method equals head, and behind that is hidden a function call. So, and that's down here, the set method function gets called. This seems a little bit like, okay, why would we ever need that? But it's interesting if you want to like abstract. I mean, for the HTTP part here, it's kind of not really interesting, but it gets more interesting if you try to abstract network connections over like types. For example, in your RAI script, you create a type that mirrors a remotely connected system for whatever reason. And as soon as you set something or get something, you actually don't set locally, but you query something from a remote server. And that's where this like feature is interesting. That's also the reason why I stumbled over it, because I needed some kind of this feature. Okay, well, then the final part is more or less we create our engine, we add the module in the main below and register it. Okay, but now the thing is, currently everything is done on compile time. As I said before, if we go for IDLs, we might not want to do compile time stuff because we don't want to compile our program every time we add like new functions. We can do the same thing completely on runtime. I mean, kind of on runtime in this snippet. This does not show completely right. Close enough. Close enough. Okay, so what you see here basically unwraps the POC macro we had from before. And instead of just having a macro invocation that builds our module beforehand, we just set everything ourselves. We set native functions, give them a name, point to the function. But this is still not as dynamic as we might want to, because sometimes we have like, who of you writes Go code or coded in Go, that there's this pattern maybe also it's also very present in functional languages, where you build a stateful function. And you can do the same here in Rust and RAI as well. So those here, for example, our new request is more or less a pure function. The set method, okay, maybe not, but the send gets also transformed into a pure function with the first parameter being the request. If we now want to have a function that gets like generated, or actually the function gets generated on runtime. For example, we read like a specific name from a config file and want then the function to have that name in there. But then we can't actually statically type the function anymore. But RAI still allows us to do this by, instead of adding here the new request function, referencing this here, and do a dynamic dispatch. So boxed in FN and then build like a closure, a Rust closure ourselves. Okay, so, oops, okay, there we go. Okay, so that's all good and all fine, but sounds promising, but not everything is good. And we also have some stuff that I have some stuff that I don't really like about it. For example, if we write like daemons or some kind of network or servers, clients, whatever, most of us usually use async coding because also most libraries nowadays in the Rust ecosystem are async. And Rai does not support async. So we have to kind of work around that by using have our script executed on a separate thread that blocks and then use something like the Flume channels. I don't know if people know them, but they're basically channels that can that have both sync and async interfaces. So you can send from sync into an async context and from an async context into sync and block on or in the async to have to do this. It's a future and on the sync blocks. That's one point. And okay, that's not there. There should be another. And the other point is, as it runs on its own thread, what happens if the thread blocks? We can't actually cancel. We can't cancel a thread. You can cancel it in C. There's like this pthread cancel method, but then we have to do cleanup. For example, if we cancel a thread, all our jobs aren't actually run. All our job methods. So how we use this, for example, if we have user code and the user has a while true in there, but we don't actually want to provide we actually want them to be able to write while functions or loops in general. So that's a thing, a little problem there, and the solution to this is similar to what browsers do. For example, if you open Chrome and then open, at least in Windows, and the task manager, or use HTOP or on Linux or whatever, and you see every tab is its own process. And you do something similar here with, you have to do it with Rai if you go into the use case where your execution can actually block. So you create a child process that you can actually kill. So that's the points that I don't really like about it. But on the other hand, it has very nice interrupt. Okay, the final part I want to touch real quick is on the sandboxing. I mentioned it before a little bit. Rai allows us to actually disable specific features of the language itself. We can, for example, disable custom functions, loops, recursion. That are at least the ones on top of my head that I remember. That there are others. You can also register a callback function that gets called after every operation, where you then check, for example, okay, I'm currently at operation 100, kill it. We only have 100 operations available. This is, for example, one way you could go around this while true. Yeah, there we go. Where I actually could go around the while true issue. But on the other hand, if some user has a list of 1,000 elements, do you really want to kill it after 1,000 operations? Maybe, maybe not. Depends on you. Then going further, everything can be on read-only. Also, in a very rusty way. If you jump back to the code, you see our engine and modules are actually mutable. And as soon as you put the engine or do shadowing without the mutable, everything gets read-only. So it uses the Rust invariants or other enforcement of Rust itself to provide sandboxing, at least for engine and scope. Scope is similar to engine, where if you execute a script, you have your string as a script or your AST, and the scope is just more or less a little more complex hash map with your variables in there. Yeah, stop execution after. That's what the callback was. And I mean, that's it. A little shorter than the previous one, but I hope you don't mind. Questions?
Sympathize with the difficulty of working with the problems of these blocking threads and how to cancel them. And my question is, what are your thoughts on making a JIT compiled language, for example, using the very lovely code generation framework called CraneLift?
You could go that route, yes, but then you have to like ship a compiler with it, and also depending on I mean, with CraneLift you probably compile it down to assembly, right? It's directly
CraneLift actually doesn't compile to assembly because it would be an extra step. So they don't create the assembly; they create the machine code without creating the assembly first.
I mean the machine code, yeah, not the assembly part. Yeah, but okay, yeah. I mean, I could see that, but then still, but then it's a sub-process again. You have CraneLift, you compile it down to machine code, and then you have to kind of. Could you execute it directly in memory? Probably. Could work. But as far as I know at the moment, CraneLift is a little bit unstable. Or it's not at least stable, whereas Rye is stable. It's past one. The DO has close to no issues open and is feature complete. So that was also like an important decision to make, especially if you put it like into end user code that you also ship to the customer. I maybe don't want to include experimental stuff.
Well, I haven't seen an issue in CraneLift so far, but well, it makes sense that it's not always you want to embed the entire CraneLift. It adds 2 megabytes to your program.
Well, it wouldn't be too bad. Wouldn't be too bad for most cases.
How do you decide if you should take YAML and add features until it's almost a programming language, or if you should use Rye and take away features until it's almost YAML?
I would say as soon as you need to have something like functions in there where actually you have to type some kind of logic that changes and function calls, you switch to an IDL. And before that, you keep to something that's that you can easily parse with, like Serda. You just have your structs in there, put deserialize on there, and be done with it. But as soon as you have to like move or do lambdas, whatever you want to call them, in there, some kind of extra logic, that sounds more like a programming language to me.
Cool.
Other questions?
Where? Okay. We're probably gonna kill 3 people doing this. We're just gonna.
Okay, thanks for the talk. I'm a little curious how you do recursion detection, because you can build loops by having 2 functions calling each other. So is that something you guys consider, or?
No, actually no. As far as I've seen it, it's built into Rye. You can, when you like create the engine, you can set a valid amount, or you can set an amount to recursion detection. I would think it's like per name of the function. I haven't. I was also thinking about it. Yeah, just do 2 functions and call them each other again forever, and they just have different names. But I would guess they keep a counter for each like function you call, and if one of those counters reaches, then you're not.
So it tracks indirect recursion, you would say.
I mean,
also you haven't tested it.
It would be my guess.
Okay.
I hope I didn't misunderstand the whole thing, but I assume there are some use cases where you could either use Rye or you could use Pio3 and expose like bindings Like, what would be like your number one reason to go with Ray
Deploy it as a
versus?
single binary on a system where you, or as soon as you cross compile stuff, and deploy it as a single binary or deploy to environments where Python isn't available.
Fair enough. Yeah.
Those are basically the only reasons. As performance-wise, it's okay. Also, yeah, I mean, don't try to.
Probably doesn't matter too much for the use cases, right?
Yeah, it usually doesn't matter for the use case, the performance, at least in this like area where you decide to go with either Python or Rye. Yeah.
Also, don't forget about the ability to turn off features. If Python to someone, he's going to use the full power of Python to fuck with your shit. And if you give them Ray, you can say no. You don't. So, if you have any kind of user-generated code that you want to run, Y allows you to say no to, the first level of stability.
Cool. Maybe can I have a very small follow-up? How's the IDE tooling around Rai? Is there something like plugins for
I don't know.
VS
There
Code,
could be
Maven?
something.
Okay, cool.
There is like at least
there is LinkedIn for VS Code also, and they provide a couple of plugins also. You can just check your code, or health check your code. So there is things. Anyone? No?
Dangerous.
Yeah. No. So it looks like a lot of people here are familiar with Rai. Like, are you shipping Rai in production somewhere? Or
No.
No? Yeah. You want the box? Go ahead. Just answer. Sure.
So yeah, maintainer of the cargo generate tool, and we ship Rai basically. I mean Rai support actually. So users can have their template. So it's about you template your code, and then you run it, and you get questions asked, and then it generates the real code, right? So you can either use Liquid, which is a templating rendering engine, or additionally you can use Rai, and then you can define your own functions, for instance, and then basically those functions, this Rai code lives in the GitHub repository that you clone, and then this gets executed by Cargo Generate afterwards. So a template or template author basically can ship that, and then the user executes this. So gives a lot of power for customization. But yeah, we have just a limited set of functions enabled, so you cannot really mess a lot with the user system, so for security reasons. But yeah, works, and users are super happy about this, sort of customization capability where the normal language, doesn't give you anything anymore. Then they go down this route.
like somebody else shipping Rai. Like I'm just curious, like if somebody else has like.
I mean, we are currently we are building a POC with it. A POC. Yeah, but depending on how that goes, we might in the future. So, and I think there was one question down there.
So one last note for because we're talking about running user provided code, and earlier you mentioned process isolation. So one consideration that should be on your mind is also these hardware side channel attacks like Spectre and whatnot. One reason browsers chose to do process isolation is that it mitigates some of the problems of these hardware vulnerabilities. Well, so that's something you should keep in mind. It's a complex topic. I've given a talk about this, but the idea is at least look into it if that's something that's in your model. And
yeah, cool.
I'm sorry, I didn't ask a question. Just hijacked the format. I know.
No worries. All good. All fine. Okay. Anyone else? Otherwise. we're done. Okay.
All right, that's it for today. See you next time, either live or in the stream. See ya.